All right, thank you. Yeah, thank you everybody for coming. I know it's getting towards the end here, but I really appreciate the attendance. I did want to mention before I get started, my coworker, Aaron Colcord, had a big part of this presentation as well. He was not able to make the trip, but just wanted to give him some credit here. So yeah, my name's Kevin Mellott. I'm the technical lead and a Spark developer for FIS Global. And a little bit more about our company. We are a Fortune 500 company in the financial technology industry. And so the majority of our business is performing the more traditional banking services, credit card transaction processing, back-end server processing for all the banks and credit unions around the world. But our specific team was actually born in San Francisco about 5 years ago. And our product is around a mobile application that banks will use to present as their own, but we're actually running and managing the software behind that. So if you go to the App Store, find your bank and download their app, there's a really good chance that that's actually running our software behind the scenes. And so my team interacts with all of the data generated by those apps. So if you think about the various workflows that you might do, historically, way back in the day, none of this was digital. So you're dealing with all the paper, balancing your credits, your debits. Really hard to understand what's occurring in that scenario because none of it's tracked. Move forward a little bit where banks began to start having online presence, and then you start to get a very basic understanding of what people might want to do with those workflows. And then fast forward all the way to today, people are not only comfortable with the technology they're using, but they're expecting that technology to be available and to be used anywhere they go. So the opportunity this provides us is that we now have the ability to really understand what our customers are doing and to capture that data no matter where they are, and to use that to better experience their workflow on the site. So some of the major things that people do are pretty obvious, but the point I'm illustrating with this slide is that people don't typically have the big leather wallets with all the cards and the pictures of the kids and that sort of thing. We're moving into an entire digital world, and so this really opens up a whole new window of opportunities when it comes to fraud detection. So some of the data points that we now have available that were not previously are all around the transactions, right? So the frequency, the location, all these patterns we can recognize, and also being able to analyze the items that you're interacting with and you're purchasing. And so the algorithms that are out there today, I mean, there's a lot of them that people are using. They're very complex, but at the end of the day, they're essentially looking at transactions, and they're not always focused on users and user interaction with their apps. So one of the downsides of this is that we're catching things later in the process. So we can detect that fraud's occurred and we can cancel that transaction, but it can be more costly and more detrimental to the workflow of the customer. And so we can do better than that, right? So if you go to dinner and you have a big bill while you're in San Francisco today, if that bill gets declined by your credit card company, it's not really a great thing for you. So if we have our mobile phones with us all the time, we want to find a way to take what people are doing on those phones, recognize where you are, who you are, what you're doing, and have a way to still give you the protection you need when it comes to fraud detection, but not leave you hung out to dry when you're really trying to get something done. And a really big part of this is the advances in technology. So the biometrics afforded by mobile phones, Touch ID, Face ID, these kind of things. And just based on people's habits, I mentioned before, you're going to have your phone with you, so it gives us information about your geolocation and where we last knew that you were. So with all the different security features that are allowed to be used on a phone, we can now understand what you're actually using and use these types of things to figure out if you really are who you say you are, or if you're just some person impersonating your account. And then the other big part of this is to make sure that this is a learning activity, that we're gathering all the data we can and using that to make our models more accurate and more correct over time. So the main scenarios to look at for this are around individual behavioral patterns, also looking at all the different devices that you might have, and then figuring out, again, within the given transactional scope, does this look like something that is reasonable to occur? And then back to that traditional fraud detection example, these are things that are usually involving some fraud experts, a group of people that have a lot of very specialized knowledge to create a large training set of transactions to label all those as fraud, not fraud. You've probably seen a lot of examples around this, so I won't go too deep into it, but at the end of the day, it's essentially a very complex version of anomaly detection. And so some of the problems with that is that building that training data set is extremely difficult and costly if you're just looking to get off the ground. And also it's not really taking into account individual user behavior. You're just looking at a transaction compared to other transactions. So we're not trying to replace all of that. We just want to make it better based on some new capabilities and data points that have been made available. So along those lines, for a particular action, we want to be able to figure out, is this normal for this type of person to perform? Realizing that people are different and they have their own tendencies, and that's really what we're trying to get into here. And it doesn't always have to deal with a transaction that you're doing. It doesn't have to be sending money to your friend or paying for a bill. This could just be ways that you are navigating through the application or ways that you interact with your technology. So things that are able to be captured with every action you take are more the physical behavior of your device. So understanding your phone's details, the makes, the models, the OS, where you are again, and the Wi-Fi network that you usually connect to. So not tracking, this is Kevin's living room or anything, but a more anonymized version of that to be able to compare. And again, with all the different authentication details that are supported, people usually levitate towards a single one. So you're probably not going to use your thumbprint to get into your app and then just switch to username and password. You're going to develop your preferences over time, and that also gives us more indicators as to if this is a real legitimate transaction or not. Payment methods as well. If you begin to send money to a bank account we've never seen before, that's another obvious data point to take a look at too. And then with devices, have we seen this device before? And if we haven't, what's the right process to use to validate and verify that that's a valid device for you to perform some sort of money moving transaction? And finally, there's some time-based behaviors as well. So some time series analysis around things like paying your rent on the first of every month. So that money is going to be going to the same person, your landlord, same amount typically, and if you start to see these things happening 5 times in a month, that's another red flag. Looking at sessions, so logging into your account and performing a transaction. You can't do this at the same time from San Francisco and from Florida. That's another kind of obvious one there, but also the time since your last transaction. So having the geo-coordinate data of what you're doing, we can tell that if you complete a transaction here and then 10 minutes later you do the same thing on the East Coast, then that's just not physically possible. And then finally, user tendencies. Depending on what your normal habits are, it may or may not be typical to purchase things at certain times of the day. So seeing as devices keep coming out, this becomes a bigger problem for us as well. So you look at all the voice assistants like Alexa, Google now, all the stuff that's being built for the connected home, smartwatches. These are all devices that are becoming a part of the banking ecosystem, and we need to figure out how to manage these and how to validate them as we move forward. But again, with those, you're usually going to use the same device when you're doing a major transaction like sending money to a friend. So the big piece of this is that when you use this device for the first time, we want to be able to figure out how can you prove that this is you. So another great example of authenticating with your biometric information always gives us a way to activate your privileges on that device and to have a baseline so that when we do think something's wrong in the future, we can just ask you to perform this step-up authentication and allow your transaction to go through. So it's a much nicer workflow than having to call your credit card company and try to prove over the phone that you are who you say you are, which is another area where a lot of the social hacking come in the past. And so then with the more traditional analysis approaches, this is where we can look at the so-called weird transactions. So something that is a normal behavior for a merchant is going to look a lot different than somebody who's just an individual purchaser. The example of buying 20 laptops on one order, that's fine if you own a laptop store or reseller, but it's not going to be normal for a college student usually. And this isn't something you have to do manually, so you don't have to go and relabel all your data. You could use something like K-means to cluster your customers based on their activity and their behavior, and then to figure out what are the different customer profiles that you've recognized based on their past behaviors. And so now getting into some of the technical details of how this all works. So the architecture here with the picture of the three people in our ecosystems, that's really 30 to 35 million customers. And so as they're using the mobile banking application to do these different types of transactions, it's sending that activity data into Amazon Kinesis. From there, we're able to use Spark structured streaming to load a pre-built model and then just to submit these transactions against that model. And so if we've determined that this is fraud, we can then communicate back with our mobile app using a queue, so SQS in this example. And then that allows the application to perform that step-up authentication to ask the customer to please prove that you are who you say you are. And then on the back end, it's been really useful to use Databricks to regenerate these predictive models as new data arrives. So this is new data not just from the app, but from many other sources, traditional banking feeds, online activity, anything of the sort. And so some more details on the actual machine learning model. It's created using the ML pipelines. And so there's a couple different phases to this. So the first is just enriching the data that's arrived. So the pre-processing phase to look at all of the device traits I'd mentioned before around the device OS, the geolocation coordinates, those sorts of things. And then to take a look at the historical data that's been used by that customer. So have you purchased from this merchant before? What's your average order size look like? Things like that. And so then moving into an unsupervised learning activity, you can perform the clustering of the customer's behavior and say, based on the type of customer we think you are, is this new action something that seems reasonable for that type of profile? We can analyze the item itself as well. So is this an item that you have purchased in the past? And if it's not, does it look like something that you would purchase based on your prior purchases? Transactional flow is saying, now that you've arrived to an outcome, so you've decided to move money in some way, what are the steps you took to get there? So essentially, which pages do you click through? That allows us to figure out, is this a flow that we've recognized in the past as fraudulent? And then finally, the time series behavior, repeat behavior around like paying rent or things that are done on a recurring basis. And then on the supervised side, we do still have the binary classification algorithm that represents the traditional fraud model, so just analyzing the transaction against all the other transactions. And then the cool thing about having all these different techniques is that they can each generate a signal to tell you, this is my opinion based on this analysis of how legit I think this transaction is. And that's where you can work with your fraud department to figure out what types of thresholds do you want to set up to determine if you want to flag something as fraud or to allow it to flow through the system. And so a big part of this is the ability that Databricks affords us to call their jobs RESTful API and to have that completely launch our Spark cluster in the background, which allows our operations department to configure what should this cluster size look like, account for scaling that way, and then to use their capabilities to just save that model into a storage area like S3. And then once our structured streaming job launches, you can load that model with one line of code. It's got all of the data and the training already built into it, so there's no need to do that after you've loaded it. And then you take all the transactions that just derived as a part of that stream and you transform them using the predictive model. And a really cool thing about this too is that the models can be stored in standardized formats. It's like a format like PMML would allow you to use this model with some of the BI tools that are out there, or to treat this model as an asset available to the rest of your organization. And so for the message broker, we're using Kinesis. I just wanted to mention this because there's a lot of these that'll work if you want to do Kafka or Azure or whatnot, but they do have a lot of very useful tools that you can look at when you're analyzing scaling. Kind of talked about this one already, but when we actually transform the data inside of our structured streaming job, there's a lot of ways you could communicate this back to your application to get that real-time behavior. And so the way that we found that works pretty well is to allow the results to be written to S3 and then to have the data that is fraudulent pushed into a queue using event triggers. And so then if you have your mobile application already subscribed to a particular queue, it'll get that notification as soon as it needs it to do the step-up authentication. And then the big part too, again, is just the feedback loop. So making sure that all of the new data you've been able to gather and label gets fed into your training data, and then you can continue to rebuild those models with the new knowledge that arrived. And with us, we can just always use the latest model, but this also gives you the ability to version your models if you wanted to do something like A/B testing. We've also done some stuff with graph analysis. So within the world of transactions or mobile apps, if you want to figure out how people are flowing through the application or analyze the relationships between transactions, graph analysis can be a useful tool for that. So we haven't done a lot with this yet, but it has been useful for us to be able to figure out our flow analysis and to figure out what are the most common steps people take to do a certain type of deposit or cash advance, that sort of thing. And again, we haven't done a lot of this, but I do think that we'll do more based on what we learned. It looks like at the time the technology wasn't really lining up to where it is now, so I've noticed a lot of newer technologies coming out of this conference I think we'd like to take a shot at. So the main thing to really recap on here is that all the stuff that's been done in fraud in the past has been heavily around transactions and not so much around just what a person does with their application based on all these non-transaction type behaviors. So, the way that you navigate through the application, the way that you've authenticated with the application. We want to bring those into the equation and make this a more customized experience for users that they can have a better time using because they won't have as much of a hard stop if a problem is detected. And I want to note too that at this conference, I've noticed that some of the enhancements that Databricks has been making around continuous processing and the Databricks Delta framework, they also look like things that would work really well for this type of system. So thank you for the time, and I put a link up here if you want to take a look at some of our other solutions or offerings, or if you want to take a look at our career jobs as well.
Thank you, Kevin. We have loads of time. Anybody for questions? There you go.
Yeah, I saw your fraud detection architect. So it looks like you use Spark streaming to trigger your model to do the prediction. So what makes you decide to use streaming to trigger that instead of just make it a like standardized API, make an API call to trigger this?
Sure, that's a good question. So for us, we use the structured streaming because we already have all our data coming into that Kinesis queue. And so structured streaming ties in very well with Amazon Kinesis. And so it became just another step in our processing pipeline that we had already established.
Yeah, but because our organization has a similar structure, we have Kinesis too, but what we did, we just use Kinesis to log the data to the S3 bucket, but we have a separate API call to enable those model to do the prediction. So I'm just trying to figure out what's the difference between if you use a streaming to trigger the API call, would that cause some latency? Because streaming is essentially mini batch too, right?
Yeah, I think it would depend on if you wanted it to be a part of your ingestion workflow or if it was more of a secondary analysis for that example. So they both would definitely work. For us, we wanted this to become a part of our earliest possible detection points. That's what we chose to do as part of the Kinesis stream as opposed to an S3 analysis after the fact.
Anybody there? Gonna make me run all the way to the back. Adding points to my Fitbit. Forgot about that. On crutches.
So I have an operational question. You're writing new versions of the model and you're reloading them in the streaming job. How do you make the transition from the streaming job that was running with the old version of the model to a new streaming job with the new version of the model? And is there a startup latency? So is there some period where you're not handling streaming events as a result of that?
Yeah, so that's a good question as well. So in my notes on the slides here, I might have been a little bit misleading. So we are regenerating the model as the data arrives, but we do have sort of a cutover phase that our operations team controls. And so you almost have to look for the time where your app has less usage, but a lot of this also seems to be somewhat handled by the infrastructure as well. So yeah, I mean, Kinesis, when you switch them out, you're going to lose a little bit when the new model comes in. But yeah, I'd say just look for the lowest usage point as you can.
So you mentioned that you persist the model to S3 using PMML, is that correct?
Yes.
In your experience, have you had any issues with using PMML, or is it a decent enough solution for your use case?
Yeah, I've not had any issues with PMML. The main thing that we decided to use for that is just because we do have a BI team that uses some tooling that will incorporate that directly. So it allows them to do some more analysis on our models and play around with them a little bit offline. So not as a part of our ingestion cycle, but more as an analysis activity.
Any other questions? Going once, twice. Well, give a warm welcome to Kevin.